Alright, so let's work through these last few examples together, and for each case, there's three cases here. There's area to the left, area to the right, and area in between. And I'll do an example for each, and then I'll encourage you to pause it and try an example for each yourself. So the instructions they're giving us here for finding area are all based on doing it in the table at the back of the book, but again, we're sticking with the calculator method, so I just want to show you these pictures. So three possibilities. First, you could have something like this. You could have all the area that's going to the left of some boundary point. So when that's the case, your lower boundary is going to be negative 10,000. That's what you put in the calculator. I mean, really it's negative infinity because this is going forever. And your upper boundary is just going to be whatever that z-score is. In this case, it's 1.23. So that's the stuff you put in the calculator if you're dealing with area to the left. Okay, what about area to the right? In this case, well, I want you to think about this. What do you think, because we're dealing with area to the right, it's on the right of the graph this time, what do you think the lower would be in this case? The lower is not negative infinity because that's way over here, and that's not what we're dealing with. So the boundaries, here's a boundary right here, and here's another boundary, it's going forever. Lower boundary, hopefully you were able to say that the lower boundary this time is 1.23. Okay, the upper boundary though is not negative infinity because negative infinity is over here, and we're going this way, we're going to the right. So the upper boundary is really positive infinity, but in the calculator you can just put positive 10,000. Have to make sure that you put positive and not negative, because if obviously if you put negative, the calculator is going to do it wrong. Okay, so that is area to the right, and then area in between would look something like this. This is my lower boundary, so I put negative 0.75 in for the lower, and this would be my upper. I put in 1.23 for my upper, and that's when I say put it in, I mean put it in normal CDF. Okay, all this stuff that they're talking about right here is how to do it with the table. You can certainly read that and learn how to do it that way if you wish, but I recommend using the calculator as an easier way. Alright, so let's do this one together. We want to find area to the left of negative 0.99. So what z-score is in the middle? It's always 0. Negative 0.99, let's say, is about right there, and we want this area. So first question, is that area less, is that more or less than 50% of the graph? And I would say it's definitely less than 50. So we should get an answer less than 0.5. So you go to normal CDF, that's under second vars. And what's the lower, what's the upper? Well, this should be lower, this should be upper. Mu is right here. Mu is always going to be 0, and sigma will always be 1, because this is a standard normal, meaning that we've changed everything into z-scores. Alright, so what is the lower boundary? We're going this way forever. That's negative infinity, so we'll use negative 10,000. The upper is right here. The upper is the right boundary. That's negative 0.99. So put those numbers into normal CDF, just like you see them there. And we said we're supposed to get something less than 0.5, and you can see we get 0.16. So that means that 16.11% of the area in that curve is found in this region right here. Alright, see if you can pause the video and try the same thing for 2.13. So I'll just sketch that here. Here's 0. 2.13 is going to be over here. First question for you is, is that going to be more or less than 0.5? And that's definitely going to be more than 0.5. That's going to be almost all the area. So do the same thing with normal CDF. See what you get. And hopefully you got this right here. Okay, the lower boundary for this would have been, again, negative 10,000. And the upper boundary is that number, 2.13. Mu is still 0, and sigma is still 1, just like always. And it looks like almost all the area, 98%. This is 98.34% of the area right there. Alright, I showed you a left example. Let's look at a right example. So here's how you find area to the right of a z-score. Again, we're at 0 in the middle. We're dealing with 1.06, which is going to be a positive z-score. That's on the right. And we want area to the right. That's why I think it's helpful to shade, just so you can have a visual. So we'll put in normal CDF again. That's under second vars. And I want you to think about this. What are the lower upper boundaries going to be? We'll fill in our 0 and our 1 right here. That's mu and that's sigma. Alright, so what's the what's the lower boundary? Because the lower always goes first. The lower boundary is this right here. That's like the left boundary. It's going to be 1.06. The upper is going forever in that direction, so it's going to be positive infinity, but we can't put infinity in a calculator, so I'll just use 10,000, because 10,000 is such a large z-score that it's practically infinity for all intents and purposes. So put that in the calculator. We said, well, actually we didn't say, should this be more or less than half the graph? Definitely less. That's definitely not 50% of the graph, so we should get a number less than 0.5, and if you put that in correctly, you end up getting, it looks like 0.14, so this is 14.46%. Yours might be off slightly, depending on what number. If you're using the table, it's okay if you're, if you have like 14.47 or 14.41, or it's slightly off, it's not a big deal. If you're way off, that is a big deal. That means you're putting the wrong thing in. Alright, see if you can try, and this is just showing you how it looks on the calculator. Same as what we did. That's 10,000, 0 and 1, and you can see there's what they get. See if you can do this, negative 2.16. So let's sketch this. This is 0. Negative 2.16 is about over here. We want area to the right. Okay, so that's important. And that definitely looks like it's more than 50%. So this should be your lower bound. The upper bound is going to be 10,000. See if you can plug that in and get it. And it looks like they end up getting 98.46%. Okay, this other stuff is them showing you how to do it using the table. If you do use the table always gives you area to the left. So this is actually, that's the area to the left is 0.0154. How would you get the total area? Well, the total area is 100%. So if you did 100% minus, or really 1 minus that number, then you would get 0.9846 or 98%. Okay, and then the last one I want to show you, we did area to the left, area to the right. Let's do area in between now. This might be a little bit easier than the other one. So here's 0 in the middle. We want to go between negative 1.5. So that's going to be our left boundary, and 1.25. That's going to be our right boundary. So we want this, and it's kind of hard to tell if that's more or less than 50. It looks like it's probably more. Okay, but let's verify. So the lower bound is this right here. It's negative 1.5. The upper bound is this right here, 1.25. Okay, and then mu is still going to be 0, sigma is still going to be 1. Put that into normal CDF, see what you get. And according to this, you should end up getting 0.82. Okay, so 0.8276, so 82% of the area is right there. Okay, there is a way to do this using the table again, but it's, you can see, look at this long explanation right here. It's a little bit more complicated than it needs to be. And this is just them showing what it looks like in a calculator, just like we did, 82.76. And as they say here, you might get slightly different numbers in the table, but you're still going to be pretty close. Okay, see if you can try this between negative 2.165, that's going to be your lower, and between this would be your upper. And I'll show you what the picture looks like. It's only a little sliver of the graph right here, and it looks like only 7% of the area, 0.0733 is what you would find there. So that's the basics of section 5.1, and they just give you like a little way of kind of interpreting this. Remember, area means probability, so it means there's a 14, like if you were being asked for area to the right of 1.06, here's what this means in terms of probability. Here's 1.06. They're talking about this area, which we found was 0.146. It basically means if you were to throw a dart that landed somewhere on this curve, you would have a 14.46% chance of landing in that region right there, landing in the one. That's what kind of the connection between probability and area here. Alright, so in the subsequent sections, what we'll do is kind of start to interpret this in real life, because in real life you don't just sit around calculating z-scores, you kind of apply it to some actual scenario. So we'll start looking at that in section 5.2.